Have you ever looked up at the night sky and felt a sense of wonder? Have you ever felt that pull of curiosity? Or perhaps you've watched a simple leaf fall from a tree, spiraling gently to the ground, and wondered why it moves just so. These questions come from the grand scale of the cosmos, and from the intimate dance of everyday objects. These are the very heart of physics. Physics is simply the story of how everything works. It's the rulebook for the universe. It explains the motion of planets. It explains the heat of the sun. It explains the light from a distant star. It explains the tiny particles that make up you and me. It's the quest to understand the fundamental principles that govern reality itself. This journey will peel back the layers of our world, revealing elegant and often simple ideas. We will not be diving into complex mathematics, nor bewildering equations. Instead, we'll explore core concepts using plain language and clear step-by-step thinking. We'll cover motion, forces, energy, gravity, and the building blocks of matter. Why care? Because physics is everywhere. Prepare to look at the world in a new way. At its most fundamental level, physics begins with the study of motion. Motion is simply the act of an object changing its position over time. Think about it. A car driving down the road, a planet orbiting the sun, an electron buzzing around an atom. To describe this movement, we use concepts like distance. Distance tells us how far something has traveled. Speed tells us how quickly it covered that distance. If you know how fast something is going and in what direction, you have its velocity. Motion is the very language of change in the physical universe. Imagine watching a train travel along a straight track. Note its starting position. As time passes, its location is different. This change is motion. Measure the distance it covers. Use a stopwatch to measure the time it took. Divide distance by time to get average speed. Example: a bowling ball rolling down the lane toward the pins. A change in direction, even at constant speed, is acceleration. Activity: mark 1 meter, time your toy car or marble, and compute speed. Try a gentler push and a harder push to compare times and speeds. A simple calculation with big implications. If motion is the what, then force is the why. An object doesn't just start, stop, or change direction on its own. Something has to make it happen. That something is a force, simply a push or a pull exerted on an object. Kick a football, lift a bag of groceries to counter gravity. Both